Now we're going to review two rules of trigs that you learned last year, so you're going to recognize them, the law of sines and the law of cosines, right? Do you remember that the law of sines can be used with any, well, both of them, law of sines and cosines, can be used to solve any triangles. They might not be right triangles. So we can't use Pythagorean theorem, we can't use SOHCAHTOA, those are only for right triangles, but we can still use that all the angles of a triangle add up to 180. And, of course, law of sines, law of cosines. So here's the big reveal. Here is the law of sines. Sine A over A, sine B over B, sine C over C. Where, of course, A, B, and C, the capital letters, are the angles. And then the lowercase letters are the sides that are across from those angles. So that's how it's always set up. So here angle A is 45 degrees, little a is the side, that's 83, little b is 79, and they want you to find angle B. So we're going to set this up, sine 45 over 83 equals sine of b over 79. This is actually kind of a harder one to start with because you're solving for an angle, but you're going to cross multiply, you're going to remember this, and then divide both sides if I can jump ahead by 83. And then when you type that all in your calculator, you'll get a decimal, but that decimal is the sine of that angle. So you want to do the inverse sine of whatever that answer is. That's the easiest way to do that. And you get angle B is equal to 42.3 degrees. The next one is a little bit more easy, I think, when they're trying to find a side. So angle A is 40 degrees, angle B is 60 degrees. Side C there is 20 degrees. So the first thing I got to realize is those add up to 100. So my leftover angle C there would be 80 degrees. Yes, 80 degrees. And then I can use that 80 degrees if I want to say like sine 80 over 20. Sine 80 over 20. Let's say that I'm trying to find side A. So we'll try and find that one. That would equal then sine 40 over A. And again, I would just cross multiply that, put everything in my calculator, make sure I'm set in degrees, 13.05. So those are the two examples of law of sines, one finding a side, one finding an angle. Here is a new formula. This is new. I don't think you did the height, the area formula for a triangle. This reminds me, I'll just write that for a second and then I'll go back and explain it. So it's a new formula for area of a triangle that does not use the base and the height, which is so nice. So, and I can explain why this formula works, but you could just be like, I'm sure it works, right? And it looks like there's three versions, but they're all kind of side angle side. So if I plug this in, A is 6 and B is 10 and C is 40 degrees, it reminds you of two sides and an included angle. And then if I use the exact letters, this would be like 1/2 B times C times, oh wait, this one would be, oops, what would it be, which version? It would be the area is 1/2 A times B times sine of C. But I usually never even write that down. I just like right away plug it in. 1/2 times 6 times 10 or whatever times sine of 40 degrees. And that turns out to be, when I type it in my calculator, 19.28. Done and done. Doesn't even have to, matter what the decimals or anything are. 9.4, 13.5, 95 degrees. Side angle side again. So it's 1/2 the side times the side times the sine of the included angle. And if you type that all in your calculator, 63.21. You do need to know that for the test. Last thing, law of cosines. Again, this can be used for any triangle. It doesn't have to be a right triangle. There's three versions of it, kind of like the last formula that we just did. And with these, I really more memorize a pattern, and it's kind of a side angle side thing as well. 35 degrees, 16, 19. Again, I'm given side angle side, and the law of cosines helps me find the side opposite the given angle. So this one, if I go with the letters, is the first version. A squared equals 16 squared plus 19 squared minus 2 times 16 times 19 times the cos of 35. And you're going to type that all in your calculator, and then you'll get like a number, right, which you have to take the square root of, And you could just do that kind of all at once, and 10.91. The only other version of law of cosines is when you're trying to find an angle, okay? So they're giving you actually side, side, side. So let's say we're trying to find angle C. So for this one here, I would use this version, where c squared, 15 squared equals 11 squared plus 13 squared minus 2 times 11 times 13 times the cos of c, and that's what I'm looking for. So here I got 225, this adds up to 290 minus 286 cos c. Common errors, people think you can subtract those and get 4. They are not like terms. You're going to need to move the 290 over, so you get negative 65 equals negative 286 cos c, and then divide both sides and take the second cos. Right? The signs will cancel, so you can just type that in, and it's 76.86 degrees, finding a side. The last two are, story problems. 2 ships, 50 miles per hour. Remember that rate times time equals distance, right? So if it goes north at 50 miles per hour for 3 hours, that would be like 150. 15 degrees east of north, 45 times 3 is what, 135. How far apart are the ships? So again, it would just be like x squared equals 150 squared plus 135 squared minus 2 times 150 times 135 times cos of 15. And then we would take the square root of that answer, right? And, that's annoying to type that all in, but that's really the worst part. 150 squared plus 135 squared, I'm typing it in, minus 2 times 150 times 135 times the cos of 15. And then I take the square root of that answer, and I get 40.06. Last one, city lot, whatever, 50, 70, 85. Find the measure of the smallest angle. Do you remember which angle is the smallest angle? Right, from geometry, the smallest angle is across from the smallest side. So 50 squared equals 70 squared plus 85 squared, 2 times 70 times 85 times the cos of what you're looking for. So 50 squared there, 2,500. 70 squared plus 85 squared, I get 12125 minus... So this is 11900 cos x. And you know how to algebraically solve this. I'm not worried about it. I'm just doing this on my calculator. And then I'm taking the second cos of that final answer, and I got 36.01 degrees. So hopefully you remember doing both law sines and law cosines last year. And that's it.